Hey everyone, what is going on? Welcome back to another video. In today's video, we're going to be looking at some PCAP from one of Hack the Box's challenge room Sherlock type deals, Knock Knock. And this is actually a room that I was going through previously using Security Onion, and then I stopped and I was like, well, how about I take this PCAP and go through the steps again and show, just how I was utilizing Security Onion and a lot of the features in the SOC to kind of carve through the data using Zeek and Zerkata and a lot of the OQL, the Onion query language, and show just how I was utilizing it and to solve a lot of the challenges, a lot and get the questions for this particular challenge. So yeah, let's just go ahead and jump right into it. If you're not familiar with Security Onion, it's a really cool suite of tools. This is an import node that I'm using for PCAP. You can also import EVTX logs from Windows systems. So I think there are some more challenges with Sherlock that revolve around EVTX logs. So maybe in another video I'll get to that one, but in this one we're going to be focusing on PCAP. And let's go ahead, and I've already SCP'd the PCAP file over to the import node. And here's a little bit of background information on the challenge. Apparently there was a server that was compromised, and just out of convenience for us, there was a 2-day packet capture, and I think the PCAP was like, yeah, it's like over 250 megabits. So it's pretty big. Now, there is a feature in Security Onion where you can go to administration, actually, no, excuse me, grid, and then drop down the little arrow here and upload PCAP right through the GUI. But I don't know if it imported properly because it only says that you can import like 25 megs. So I did it the traditional way. I have been able to import PCAP, below 25 megs, no problem. So maybe it's just I was impatient, but I decided to do it through the command line. But yes, you can import EVTX logs and PCAP through the GUI, which is really cool. And another thing, right? So if you're an administrator in a SOC, one thing you want to be cognizant of is your Zerkata HomeNet. So Security Onion made really cool features for modifying all the major configuration changes inside the SOC. So it's as simple as going to administration and configuration and coming down over here to Zerkata HomeNet. Now I had a peek at the PCAP, so I kind of knew what the internal private subnet was. So I'm pretty sure maybe this might have covered it, but just to play it safe, I had this in there. And then I committed it, and then I synchronized the grid, and it took, right? So let's go back over here to the command line. So it's as simple as sudo so import PCAP and then the captured file here, and then putting password. And then there we are. So first it's going to verify the file, then it's going to store it with a unique hash identifier in the NSM import directory, and then it'll start parsing through it using Zerkata rules to hit on any strings that might be apparent in the PCAP, and then also it'll start parsing it with Zeek, depending on how many resources you give. Your import node would, I guess, depend upon like how fast this will happen. So we'll just let this run just for a second. So hopefully it should take, but maybe a few more seconds, and then once that's done, it'll spit out a nifty URL link that you can use with a specific import ID that'll take you straight into the hunt, so you can kind of get like an overall visual on everything that you have. So like I said, I started solving some of these challenges, and I got stuck at one, and then that really forced me to really dig deep into Security Onion, looking at PCAP and other OQL queries and things like that, and kind of jumping back around. So I just kind of wanted to show this. This is actually pretty cool. We might try to solve the whole challenge set. I haven't completed everything yet, so we'll see how long this takes. But here's the URL for our PCAP that we imported. So just go ahead and copy that real quick, and you can just plop it into your search bar, and boom, here we are now. We're under the dashboards tab, so this will give you kind of a quick highlight on everything that you have. All the event data sets, your observer node's name, the event module, some really cool Sankey diagrams, and this is really malleable up here, so you can take this and move it over here or add here. We'll see that here in just a moment, but this is just a quick snapshot of everything you have from your import PCAP. Now, if we go over to alerts, and one thing actually I want to mention is we need to get the timestamp. I think I might have it right here. So this is the timestamp in which the intrusion occurred, and you can actually see that here as well. So here's the time range, right? But this is the proper syntax for the time picker. So we'll just go ahead and copy that. And here we are in the alerts. And we can come over here to our little clock. We also want to make sure that we're set to UTC because that's just universal, and this might have been captured, in that specific time frame. So we'll just go ahead and scroll on down to UTC and set that. Refresh. We'll go ahead and we'll paste this in here. And we'll hit apply. And here we are. We have a plethora of alerts. Now, these are actually a lot of alerts. I had looked at them, kind of glanced over them, but then I just kind of really just started going into the hunt and kind of messing around with OQL. But there are a lot of interesting alerts. Some of them, when I was looking at the challenges, kind of pointed me in that right direction, so to speak. Like this one, for instance, here, password retrieval from a Linux system, the shadow file as well. So I thought that was interesting. Also, it was like a zip file was requested. So we'll come back to this, but this could definitely lead you in the right direction when it comes to trying to pinpoint exactly, what occurred. Zericon is great, but that aside, let's just go straight into the first set of questions that we have here. So we'll go ahead and play Sherlock, and here's a zip file to give you a key with it. Now, I've already answered a bunch of these, I think like half of them, and this is a retired box, so if you want to, paste in the answer and get the question right, that's fine, but we just kind of want to go through exactly how we would use security to find a question such as this here. So let's go ahead and jump right over into the hunt. So we get rid of this. We'll go into hunt, and we'll set our time here. And here we have all the different source and destination IPs. So let's go take a look at the first question. Which ports did the attacker find open during their enumeration phase? Now, I guess it's one thing we probably want to do is find exactly what our attacker IP is. I wish this time value would stay the same, but it's okay. So looking at these particular alerts, potential FTP brute force. All right, let's start with that there. We'll just left click this and drill down. And we can see here that this is our source IP and our destination IP. This is definitely a private IP. So if I would have to make an educated guess, I would assume that this would be our attacker IP. So we can just copy that here. Let's open Hunt in a new tab. And let's go ahead and get our timestamp here and apply. Let's just go ahead and start racking and stacking. So we'll get rid of that there. Let's go ahead and fold up. What do we have? Okay, group observer name. Let's get rid of that. All right, we just have a star for everything here. So let's do, I think we're looking at, let's see our source. So we want to see what's coming from our attacker IP. So it's kind of the source IP, which is right here. We'll go ahead and fold this up to the top. And you can see we have a nice new column here. Let's just go ahead and include this particular IP, this source IP. And let's go ahead, and I believe this will be right here. This is going to be our target, so to speak. We look back at alerts, 39.46. So we'll just go ahead and we'll include destination IP here. And we can go ahead and fold this up there. And destination port. Now, if this is scanning, this might be a lot of different ports, but we can do that as well. Let's go ahead and put in destination port. And let's go ahead and rack those. So we got 14, 21, 22. So FTP, SSH, 80, 443, 3306, which is MySQL, I'm pretty sure. And the question is asking us, which ports did the attacker find open during the enumeration phase? And so if a port is open, then I would say it's safe to say that there was an actual connection there. So we can look at, let's look at connection state here. Let's go ahead and fold that up. Okay. So if I had to guess, I would say that if the port is open, probably a connection was established. So we'll go ahead and include this here. And this is how I pretty much came to the determination of which ports were open. But this one threw me off. So you see how easy it is to pretty much, rack and stack. Okay, we have our source IP, our destination IP, our destination port, 21 all the way up to 8086 that had an actual connection established. So from a scanning perspective, if they were using mmap, send fin, they actually connected to the port, it was open, and it sent back a response. So this is what I used here, this particular OQL that you can actually copy and paste and use for later if you'd like. And it actually saves it here, I believe, for a time, and then goes away. But so we have these ports, and if we go back here, we can actually see that 21, 22, 3306, 6379, and 8086. So there we are. So that's the first one, and that's kind of how I got to that conclusion there. So let's pop over to the second one. What's the UTC time when the attacker started their attack against the server? So if we go back to our original OQL, we can add in timestamp column here. And what we can do, which is pretty cool, we can move this over if you'd like. Let's go ahead and get rid of that. And we'll put it in front of destination port. You can see how we moved, we shifted that over if you want to, kind of keep everything close in a close narrow view. We can see that it looks like 10:42:26 might have been the original time, the initial first time that the attacker may have started their attack. We see 10:42:23 here. 10:42:23. So let's go ahead and wrap these. Yep, so we definitely see that the first time they started their enumeration and actually connected to a service was at 10:42:23 UTC time. So pretty easy in that sense to move your field, your event field around, kind of get a nice view of exactly when things transpired in sequential order. So easy enough there. We were able to answer that question. And then for task 3, for the MITRE attack ID that the attacker used for initial access, I did a little bit of research of my own, and if we actually look up this MITRE attack ID here, Just go ahead and Google it. We can see that's brute force password spraying. Now, how did I come to that conclusion? Well, let's see here. We go back to alerts. We can see that there were multiple FTP brute force attempts, and excuse me. Let's go ahead and click down and look at PCAP on this one real quick. And okay, so we'll go ahead and expand this out. Now, if we look at this particular PCAP, this stream or for Zericata alert, we can see that they use Tony Shepard, they use Lynn Bailey, so multiple different. Let's see, is there any more? Yeah, so just for this one in particular, they use a few different, actually a couple different usernames with a variation of the same password. Actually, let's go back here. Let's click on another Zericata alert and look at the PCAP and see if the usernames change. No, so the password changed, so you can see a different password. So definitely password spraying was occurring here, which is, you know, initial access TTP to get into a service, spraying a service, an open port, whatever it might be offering up, whether it be, you know, SSH or FTP, to potentially gain access, right? So brute forcing, password spraying. That was the particular MITRE attack ID that I came up with for task number 3, right? And we'll go ahead and head on over to task number 4. This is where we're going to start digging into some of the pre-made OQL queries. So if we look at, we go down, since we're seeing a lot of FTP action here, we can pivot on over to either FTP, user FTP argument or command. So we'll just take a look at this here. And we can see that there were a lot of different arguments with different usernames here. Tony Shepard being one of them, and Abdullah being another username as well. And if we see here, we start at 1051 and we see Tony Shepard, Tony Shepard, Tony Shepard, and then we see a file size here. And then there was this weird, I would assume this is an FTP service. Maybe the protocol is the same, just the port's different. But let's back it up to potentially this particular log and see if a username was given with the correct password to be able to then interact with this backup file of some sorts, right? So let's go ahead, go to actions and PCAP. And if we start at the top, we see user Tony Shepard. Please specify your password. This is the whole packet. And then we see summer 2023, bang, and log on successful. And this happened at 10:51, if I'm not mistaken. Go back down here. No, 10:52, yeah. So 10:52. And Tony Shepard with summer, which was it right here? Yep, summer 2023. So it would appear that these are the credentials that they use initially to hop onto the target, so to speak. So that was task number 4. Task number 5 here, what is the malicious IP address utilized by the attacker for the initial access? If we go back to our alerts, and we'll just spend this out 24 months, and we see we can do, let's do this one here. And we'll go ahead, and we can see there's a lot of different source IPs here. Root login attempts from a single source. Same target here, same target. And there's a lot of alerts, a lot of alerts. Let's go write these by the count. Yep, 3306, MySQL. Let's go look at destination IP here. And we have a lot of these alerts from the 3.109. And this kind of, like I said, marries up with the attacker IP that we were looking at originally. Now, an educated guess might take you in a couple different directions. It just so happened that when I saw, we go back to here, name and module, I kind of started just working my way down the line, and we'll go to highs. We'll start here, and we'll drill down. It was just quick and easy to see that 3.101 or 3.109 was a particular IP of interest here for me to look at. Just so happened to be up at the top, and that's what I went with, and that led me to answering task number 5. Right now, for task number 6, what is the name of the file which contains some config data and credentials? So this is kind of cool here. We can see that they authenticated as Tony Shepard, and then there was some interaction with this backup file. Now we can look at the PCAP more in depth, and we can see that there was a listing of directories here after they successfully authenticated, and they perused around, and then looks like they switched it up a little bit to be able to grab this .backup file. But in this particular context, we're just looking at, you know, like a TCP stream, I believe. I could be wrong, of just what was happening with connections and files, not the actual file itself. So what I did here was I took a look at the timestamp that this user was interacting with this file via FTP. So 10:52:03. Let's go ahead and duplicate this now. Another cool feature in Security Onion, if we take a look at a pre-made OQL or files, we can look at, we can group this by file source and source IP. And here's our particular source IP that we're interested in. So we'll just go ahead and include that one. So we see file source FTP data. And if we remember correctly, 10:52:03 was when Tony Shepard retrieved this backup file here. So what we can do is we can hone in on this, and of course go to actions, PCAP, and we can quickly see exactly what were the contents of this particular backup file. And it took me a minute after looking at it. I mean, obviously the answer for the question, I believe it was task 6. What was the name of the file which contains some config data, .backup. So this had some configuration, you know, contents to it, and I really didn't know what I was looking at to begin with, so quickly answered .backup. But you could see how easy it is to look at the data in the SOC, primarily just in the SOC, and figure out exactly what's going on when honing in on source and destination IPs, particular usernames, and so on and so forth. So very, very easy. We were even able to pivot over to a file source and pull the PCAP back and analyze it all in the SOC right there, which is pretty cool. But we'll get to this one here in a moment. It took me a little while to figure out what was going on here, so yeah, we'll hold on to that just for a second. So .backup for task 6, pretty easy. Which port was the critical service running? Critical services could be, I guess, anything critical to the server, right? But I mean, I guess it's self-explanatory. But what port, right? So that led me back to my original hunt that I was conducting, which were what connections were actually established, right, with the source and destination IP. And this was the outlier here. So this target had port 24456 open on it. They were able to establish some sort of connection to it. I don't see any other ports that had a successful connection established with the source IP. So this was my educated guess that something was running on this target that allowed the attacker to connect to it. And that was, how I was able to quickly answer 24456 was looking at my original hunt with connection established, and it was just very simple, very easy, very quick. You could do this in Wireshark. You can do this just with Zeek on the command line. But when it comes to answering those questions fast, quick, and accurately, I mean, Security Onion just kind of like brought it home real easy. So that was how I was able to answer that particular task, task 7, right? Now, task number 8, I had to do a little bit of thinking. The answer was very obvious after I kind of, bounced back and forth between looking at this configuration file, looking at, exactly what's going on here, so on and so forth. I came up with the answer port knocking, and it was, obviously in the challenge as well, knock knock. But I think what really led me to it, to kind of sum up what technique was being used, was really focusing in on this configuration file here, right? And if you look at it, it kind of makes sense when you read it in order. So sequence equals, 3 different high ports in a very particular order. So I did a quick Google search, sequence of ports in order. I could actually probably just maybe like and I think I just kind of Googled around a lot. Sequence of ports in order for service open, and I started looking at it. It's like port knocking. Kind of went and found some other open source research, and essentially that's what led me to, oh wow, this configuration file here is saying, hey, if you interact with me on this port, and this last port, it has a sequence timeout, and then it looks like a IP tables command is issued to allow you to go straight to port 24456 and accept, right? So that's kind of like how I was summing this up here. And it looks like it's only taking SYN flags. So it doesn't necessarily mean that you have to make a SYN fin, just SYN in this particular order. And I guess this would circumvent scanning, because scanning happens in a numerical order. So you have to be able to interact with this target via these specific ports for you then to ultimately get to port 24456, which is being hosted on the target once you conduct the specific port knocking. That's how I interpret it. Maybe someone else interprets it differently, but that's what led me holistically to say, oh, one of the techniques used to get to the critical service was port knocking. So there we go. And then task 9 was, very apparent what the answer was very quickly, because it was all under one umbrella for me to look at. The sequence of numbers that needed to be interacted with in order to gain access to the critical service. So that was fairly simple there. to uncover and drill down into. Excuse me. So let's see here. Task 10. I believe there are 21 tasks. Let's see if we can get to all of them. Maybe, maybe not. So task 10, right? What's the UTC time when interaction with previous question ports ended? So let's go ahead and play with this a little bit here. So we'll go ahead, we'll include this port, but we want to see, if we look back at the PCAP, the last number that needs to be interacted with is 45087. So we'll go right here and 45087. Let's go and take our connection state established out, which is going to be this whole thing here. Yeah, it's going to be this whole one. Yeah, I'll go ahead and take that out. All right, so we have connection attempt rejected, and I believe it's just going to be the SYN, if I'm not mistaken. Or if you can see that here in the log. Connection history, no, just rejected. So a packet was sent, but rejected because the port's not technically open, I guess. I'm not sure. But take a look at the timestamps here. It looks like interaction ended 10:58:50. And that was the question, the answer to task 10, 10:58:50. So you can see just how quickly it is to see everything under one umbrella. Very cool, very easy to dial in on. Let's go back and see what task 11. So what are the set of valid credentials for the critical service? Now if we look here, let's do, I think we're looking at FTP, if I'm not mistaken. We can just go back down here and boom, there we are. And we see 24456 here is the critical service that's running, and we can do one or two things. We actually see that Abdullah is the user here, and we can actually look at the PCAP. I'm not mistaken. Let's take a look at it real quick. And we can see that they have their username and their password, which was the same, which was in the config file that was needed to authenticate to this FTP port, right? So very long, goofy password for Abdullah, which was the answer to task 11. Task 12 was kind of interesting, so to speak, because I needed to understand, okay, yes, they got access to the server, but when exactly did it occur? I could be wrong on this, but I think we want to try to think real quick how, because I had a thought on this. Let's just go and follow it real quick. And the question is, at what UTC time did the attacker get access to the critical server? Well, I guess they used Tony's credentials first, so we could probably start with that, which was, it looked like 10:51 when they originally started using Tony's username. Let's just take a look. Yeah, let's focus on the user Tony real quick. And 1051, let's look at this PCAP here and see if we can see the original. The original. So it looks like they connected the 0350, which, you know, UTC time offset, I don't think is applicable here. So 1050, no, I don't think. I don't know, this isn't the critical service that's running. I think we want to focus on this one here because it's saying critical server. So I would assume that, I shouldn't assume anything, but I would say best guess is we should start right here. So let's take a look. We'll go ahead and go to actions, PCAP, and let's look for new login authentication. Let's see here. Okay, so user Abdullah, please specify password. Okay, looks like they specified their password there. And we see a logon successful. So here we have the timestamp -7, which would come out to be 11 a.m. 01. Oops, 11 a.m. 01. I'm thinking that's it right there. And this was on March 21st. And we see log on successful. So that's when that's when I would think that the initial access really occurred. Right here. Let's go ahead and put that in real quick. So day, month, year. So 21/03 2023. What the heck? Oh, sorry. 11/00/01. All right, boom, we got that one. Nice. Okay, I had issues with that. So yeah. All right, next one. Task 13. What's the AWS account and password for developer Abdullah? So I think we probably should go back to the FTP and we can look at this now. Looks like Abdullah logged in, boom, boom, and grab this archive.sql. Now how we did with this here, we can do the same with here, looking at the actual file contents. And we see 110207. Let's go back to Hunt. And let's look at file. Yep. And let's go ahead and take our timestamp. Paste that in. Here's our attacker IP. And I think we're focusing on 110207, which is here, right? 110207. Obviously, we'll go to actions and then PCAP. And let's take a look at what we have here. So after reading a lot of this, it looks like SQL data of some sort. Scrolling down, it's kind of easy to really glance over, but if you read real closely here, we can see Abdullah with a particular set of strings. Might be their AWS account ID, and after playing around with a little bit, this information was what they were looking for. And you can see here that this is the account ID, this string of digits, with this alphanumeric password here. So you can see how easy it is we haven't once left the sock, which is pretty cool, which I like to be able to work in one GUI instead of several. Like I said, you could probably do this all in with Zeek and Wireshark or Network Miner, but this just makes it a lot easier. So, all right, let's keep trekking forward here. Excuse me. Let's see. All right. What's the deadline for the hiring developers for Gorilla? All right, so let's go back to, obviously we're looking at a lot of FTP data. Let's go ahead and archive SQL, task to get done .docs. I think that would probably be the file that we want to look at, if I'm not mistaken. So 1102.16. Let's go back to here. I don't know if we can look at Word docs in this same fashion. And I don't know if there's a way to do it in CyberChef, but let's look at the PCAP. It is a Word doc. Oof. Well, some sort of doc, it seems like. We might have to actually look at this in some sort of application. So I might have to do some Wireshark analysis, I think. But I have LibreOffice here. Which we can use, and I have Wireshark, so we'll just do that, right? We probably need to go ahead, and if I'm not mistaken, I need to go ahead and download this. Let's go ahead and download this PCAP. Did we get it? Okay, yeah, we got it, I think. Yep. All right, there it is. And let's just open this up in Wireshark. Oh, let's see here. How do we export this into like raw data? Let's just go down here. Looks like this might be it. What is this? Right here? Yeah, one of these two files, I believe, are going to be it. Oops. Can we like download this? Let's see here. How do we show data? Show data. Show bytes. That's ASCII. No, that's not it. Guess so, maybe. I don't know. Let's do file. Save as desktop. Doc. Doc.ex, yeah. And I wonder if we can open this. Oh wait, no, that's totally messed up. Let's rename that. That's like a PCAP though. Can't open that. Block. What am I doing here? Let's see here. Do some quick Google searching. So Wireshark. Oops. Carve. Word doc. Okay. Is there a quick how-to guide somewhere? FileZilla, some stuff with FileZilla. Okay. FTP download stuff. Oh wait, what do they do here? Let's see here. Pivot to WinFTP. Blah 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 blah. File detection. Okay. File recovery. Follow TCP stream. Let's do that. So let's go ahead and follow TCP stream. Let's see here. Show data as ASCII. It's what it's already in, I believe. Let's go over here. Show and save data from ASCII to hex dump. Hex dump. All right. What's the next step? What do we do? Hex dump. Let's see here. Show and save data as from hex dump to raw. Okay. Show data as. Oops. Let's go raw. Oof, it's a lot of data. Okay. All right, what's the next step? What's the next step? And it looks like they're saving the file as a docx. Okay, let's try that out then. Save as. And let's do hack the box. Knock dot. All right, and let's see if we can open this. Desktop, all files. Did I save on the desktop? Where did I save it to? Oh, I did. I saved it to this PC. Boom, there we go. Here we are. Can we open that up or no? All right, let's get rid of that right there. Urgent tasks. Okay, this looks like this might be it here. What was the question initially? I totally forgot. All this trying to figure out Wireshark stuff. What was the deadline for hiring developers for Gorilla? Let's go back to LibreOffice. Hire 20 developers by August 30th, 2023. Better be some good developers that can develop a different way to not be able to break into this box, this target. All right, hire 20 developers, August 30th, 2023. What do we have? Boom, that's it. Cool, cool, cool. Okay, on to the next one. When did CEO of Gorilla was scheduled? I don't think there's some grammatical issues here, but you know, I'm not good at English either. It's my first language. Scheduled to arrive in Pakistan. Let's go back to FTP data. And I think we're just going to keep working our way down the line here. And we'll kind of do the same thing we did for, so reminder.txt, 110223. See if we can go back to files. 110223 seems to be it right here. Go to actions and PCAP, and what do we have? I am so stupid and dumb. I know the feeling. Keep forgetting about Farilla CEO Happy Grumwald visiting Pakistan. KK. What are we looking for? Looking for a date here. He is to arrive in my city on March 8th, 2023. So when did the CEO Perilla schedule to arrive in Pakistan? Well, Let's go ahead and put this. All right, task 15 is completed. Nice, very nice. All right, task 16. The attacker was able to perform directory traversal and escape the Shroot jail. This caused the attacker to roam around the file system just like a normal user would. What's the username of an account other than root having bin bash set as a default shell? So any sort of user permissions will definitely be in that password file. And if we look back over here at alerts, we can see that there was the retrieval of Shadow and Etsy password. I wonder if we can we filter Etsy? No, didn't like that. Wow. There we go. Okay, I like this little filter. It's pretty cool. We scroll down here, drill down, open this alert up. We'll see if Zercod did any magic here. And this just looks like a lot of different retrieval. Well, we see there's a lot of listing of files, well, file directories, and changing working directories, but that's all we see there. And I believe it was the string that Zercod hit on, the string. Now, as we have been doing, let's look at Etsy password. I don't believe Shadow will have it. It might, but Etsy password definitely for sure for user permissions and things like that. So 11:03:18. Let's take a look at that particular timestamp for files. Right here is where it's at. And look at the PCAP. This is definitely it. So other than root, where's root at? I'm not seeing it. All right, here's root. So root has been bash, no log on. For the rest of these other, been false, been sh, and we have a cyber junkie here, right there. So cyber junkie, this might be it. Let's go ahead and it ends with the E. Can I spell right? Indeed, cyber junkie is the other user that has default shell. Cool. All right, let's make our way on to the next one. What's the full path of the file which led to SSH access of the server by the attacker? What's the full file path of? Well, it ends with the R. Let's go and look at our files that we have. What is this one right here? Reminder, and the opt reminders.reminder 11:05:58. Can we take a look at that particular file? Reminder doesn't have an extension on it, so 11:05:58 is right here. Obviously, we're going to look at the PCAP. A reminder to clean up the GitHub repo. Some sensitive data could have been leaked from there. If I know Hack the Box, this is definitely a clue in some direction. GitHub repo. What was the question? What's the full path of the file which led to SSH access of the server by the attacker? Now I'm looking at this file extension or this directory, here. And I wonder if that's it. But copy that in. Sorry, wrong answer. Maybe that didn't be there. Okay, that is it. So this is kind of weird though, but this is the file path which led to SSH access of the server. But there's nothing in there. It's just saying to clean up the GitHub repo. Maybe there's a GitHub repo for Knock Knock. There's some write-ups. Key scan internet for SSH. Let's see here. We don't know exactly how the attacker gained access. Well, I can think of a couple ways initially that we found. A critical Forella dev server. Do we have any other info? Crisis at Forella. This Sherlock will require an element of open source intelligence. So we're definitely going to be doing some OSINT here. I guess some key critical pieces of information. So we have a Forella company, crucial dev server. We have some users. Let's just take this. Let's do this. Forella crucial dev server. We'll paste that in. Server GitHub. Remix dev server. Forella is the company name. Forella Finance. Wait, what is this? Digital Crisis. Company is expanding its business into Pakistan. Is there anything about finances in here? Let's just take a look at this one. 9 months ago. What's today? It's December, and just so happens to be the 21st today. So 9 months ago, that would line up perfectly with we are definitely on the right track here. Cyber Junkie. Let's see here. So it looks like these are placeholders. It's just a YAML file though used for some sort of SSH access automation maybe, but we had that Cyber Junkie, which this is definitely a telltale sign this is it. See, Forella, issues, pull request, actions. Let's see here. Activity. All right, so we do have a lot of different activity here. Yep, that guy looks like a Cyber Junkie. Let's see here. Let's create test. Main. Dev, delete test. What is this? Let's click on this right here. Right now. Can we look at the file? Well, can we compare changes? Test. That's all that had. do we actually look at? I obviously don't know my way around GitHub. Well, how do we look at what's going on inside these files? Compare tests. Here we go. Aha, looks like we have an SSH password here. Let's go ahead and copy that. And fingers crossed. Is that it? Oh, that's it. Nice, nice, nice. We only have a couple more to go. A few more to go. That was interesting. That was interesting. Definitely lined up. Definitely. Cool deal. I like that. Way to go, Hack the Box. What's the full URL from where the attacker downloaded the ransomware? Actually, I thought I saw something here in the Zerikata alerts for that .quad file. What am I doing? Oh my gosh. 24 months. Yeah, here we go. Where was it? Okay, yeah, so this is what I was looking at earlier. This 13 IP address, I don't know what that is, but let's take a look. Oh, wow. Okay, so we do have an extension here. Go ahead and copy that. And it looks like it came from this IP here. Over port 80 is from, if I'm not mistaken. And let's not click on that. Copy that real quick and see if that's the deal. It ends with a P. Zip, probably, yeah. Boom, there we go. So that is the malware server, so to speak. All right, what's the tool util name and version which attacker used to download ransomware? Just looking at some of the decoded data here, I see wget. I wonder if this is it. I don't know, maybe it is, maybe it isn't. Name version. Is it wget? Oh yeah, so boom, that's it. Wget. Version 1.21.2. All right. Last one, here we go. What's the ransomware name? Good question. Gorilla ransomware, I'm not sure. Let's see here. Can we look at PCAP and just kind of zoom in on that? That looks kind of large. Ransomware. What's the ransomware name? Let's just look for ransomware. Let's actually make this a lot larger. Oh wait, no. Ooh, yikes. This is quite hefty. A very, very, very hefty file. Let's look at 1,000 lines. What all do we got? Ransomware. Nabira, ransomware 2. Looks like some other file extensions with this server. Ransomware program. Ransomware. Decryptor comp shut. Old version here. Gonna cry, wanna cry. Reminds me of wanna cry, gonna cry. Um, gonna cry. Gonna cry. Virus. Gonna cry. Ransomware. PC risk. What is gonna cry ransomware? Not exactly sure, but let's go ahead and copy this real quick and see if this is it. Gonna cry. I mean, it ends with a Y, so. There we go. Boom. There we have it. We have solved this whole challenge. Really cool. I like that a lot. As you can see here, we definitely were able to do pretty much everything besides like one task in Security Onion, which was looking at that doc file, which was a reminder, which was actually pretty cool. We used a little bit of Wireshark. Sorry, I was a little rusty there, but yeah, we got it. We're good. I hope you guys enjoyed this video. I might make another one, look at some other Hack to Box with tired, challenges. And I saw that there might have been some challenges with some host logs, so definitely would like to use Security Onion with that very much. So hope you guys enjoyed the video. Comment, let me know if you liked it or didn't like it. If there was something I could have done better, I'm always trying to, get a little bit better. So much appreciated for you guys stopping by, and take it easy.